When we look to the sky, we see not just the past but the future. Each distant star is like a flicker of possibility, a beacon in the endless stretch of time. As we stand here, on our small blue world, we face one of the most profound questions that humanity has ever asked. Are we alone in the universe? It's a question that has echoed through the halls of science, philosophy, and imagination for millennia. The answers, though elusive, are perhaps within our grasp. As we venture farther into the stars, we find ourselves standing at the threshold of a new chapter, one where science and curiosity have taken us from mere speculation to the beginning of discovery. What lies beyond Earth? Could there be other worlds like our own? And more than that, could they be home to life in all its complexity, diversity, and wonder? Exoplanets, planets that orbit stars other than our Sun, are not a new discovery. In fact, they've been found by the thousands in recent years. With each new planet discovered, we expand our understanding of what's possible in the universe. But this search is not just about finding new worlds. It's about asking whether any of these worlds might be like Earth, capable of supporting life. As we peer into the heavens, we focus on those planets that exist in the habitable zone, the region around a star where conditions might be just right for liquid water to exist. Water is, of course, a key ingredient for life as we know it. But water alone does not make a planet capable of supporting life. The right atmospheric conditions, the presence of key elements like carbon, nitrogen, and oxygen, and the stability of the planet's environment are all crucial factors. But the more we learn, the more we realize that the habitability of a planet isn't simply a matter of finding the right conditions. It's about understanding how life might emerge, evolve, and survive in ways we can't yet fully predict. Just because a planet might be Earth-like doesn't mean it will be able to host life in the way we understand it. Telescopes like Kepler and TESS have revolutionized the way we explore distant star systems. They allow us to detect tiny changes in the brightness of stars as planets pass in front of them, an effect known as the transit method. By studying these light curves, scientists can determine a planet's size, its distance from its star, and even its atmospheric composition. But this is only the beginning. The James Webb Space Telescope, launching in the near future, will take this exploration even further, giving us the ability to peer deeper into the atmospheres of exoplanets and search for signs of life, or biosignatures. These biosignatures are the key to answering the question of whether life exists elsewhere. Gases like oxygen, methane, and carbon dioxide can be produced by biological processes here on Earth. If we find these gases in the atmosphere of a distant planet, could it be evidence of life? Or might there be other, less obvious indicators of life that we're only just beginning to understand? But what if life doesn't look like what we expect? What if the life we find on exoplanets isn't based on carbon, isn't bound to water, and doesn't thrive in the same conditions we take for granted? On Earth, we've only known life as we experience it, life that thrives in water, under the warmth of the sun, and in an oxygen-rich atmosphere. But we've also seen that life on Earth can survive in extremes that we once thought impossible. Life thrives in volcanic vents, in acidic lakes, and even in the frozen deserts of Antarctica. What if, out there in the farthest reaches of the galaxy, life is thriving in ways we can't even fathom? Could there be life that survives in methane lakes, where the temperature is freezing and the atmosphere is poisonous? Could there be organisms that use something other than water to sustain themselves? As we broaden our search, we must challenge ourselves to think beyond Earth's conditions, to imagine life in all its forms, not just as it is, but as it could be. Life may not need the same elements or the same processes we take for granted. It could exist in environments we once thought hostile to life itself. Life on Earth has shown us a fundamental truth. It is far more resilient and adaptable than we ever imagined. Microorganisms have been found thriving in environments once thought uninhabitable, deep beneath the ocean floor, in superheated geysers, in the acidic pools of Yellowstone. These extremophiles challenge our assumptions about life's limits, reminding us that life can thrive in unexpected places. Could this adaptability extend to other worlds? In a universe so vast, it's entirely possible that life could evolve to survive in ways we can't yet predict. Perhaps life on an exoplanet might use sulfur instead of oxygen, or find a way to endure the crushing pressure of a distant ocean world. Could there be organisms that live deep beneath the surface, shielded from the harsh radiation of their star? Or could life even exist in the thin atmosphere of a gas giant, drifting on the winds of that alien world? Take, for example, Titan, one of the most intriguing worlds in our solar system. Titan is cold, frigid, heaving. Its surface temperature's far below freezing. But what sets Titan apart is its thick atmosphere, composed mostly of nitrogen, and its seas of methane and ethane. Here, we have a world where, despite the extreme cold, there is the potential for life forms to emerge, life forms that could use methane as a solvent rather than water. What might those life forms look like? How would they evolve in an environment so different from Earth? In the coming decades, missions like the Dragonfly mission to Titan will provide us with the answers to these questions. The more we learn, the more we begin to realize that life could be more diverse and adaptable than we ever imagined. It may not just exist where we expect it. It may be thriving in places we thought were impossible for life to survive. Our quest for life beyond Earth is not just a scientific pursuit. It is a journey of self-discovery. As we search the stars, we not only seek out the possibility of life elsewhere, but we also search for a deeper understanding of what it means to be alive. What are the conditions that allow life to emerge? How do we define life? Could it exist in forms that are so different from what we know that we wouldn't even recognize it? The discovery of even a single extraterrestrial organism would change everything we know about the universe and our place in it. It would tell us that we are not alone in this vast cosmos, that life, perhaps in ways we can't even begin to comprehend, is a universal force spreading across the stars, reaching into the most unexpected corners of the universe. But even beyond that, finding life on an exoplanet would signify something even deeper. It would show us that we are part of something much greater than ourselves, that we are not merely isolated in our small corner of the universe, but interconnected with a cosmic web of life that stretches out across the stars. It would affirm the profound truth that life, in all its forms, is as much a part of the universe as the stars themselves. In the end, the search for life on exoplanets is more than just a search for aliens. It is a search for ourselves. It is a quest that takes us beyond our earthly concerns, beyond our small lives, and reminds us of the infinite possibilities that await us in the universe. As we look outward, we gain a deeper understanding of who we are, where we come from, and where we might one day go. We are explorers, driven by a boundless curiosity, reaching for the stars. And perhaps one day, we will find that we are not alone in the vast dark. Perhaps we will find the unmistakable signs of life waiting for us among the stars. But even if we don't, the very act of searching will continue to inspire us, to shape our destiny, and to remind us of the most important truth of all, that the universe is full of wonders waiting to be discovered,